Do you know what is section formula in coordinate geometry? Let's try to understand together. So let's say that there are 2 points A and B. So A is x1, comma y1, B is x2, comma y2. So we can always draw a line between them, right? There can be always a line between 2 points. So let's say there is a point in between called P, which has coordinates as x and y. Now this P is dividing the line segment A and B in the ratio of m is to n. So we don't know the coordinates of point P and we want to find the coordinates. So based upon the information that we have 2 points A and B, and we have information that the P point is dividing the line AB into 2 parts in the ratio m is to n, we can find the coordinates of x and y, the coordinates of P, that is x and y. So how do I do that? So to find P, x coordinate of P, what I'll do is I'll use this m. So m is near to x1, y1. So I won't use m with x1, y1. I'll use m with the point which is far away with B. And similarly for n, I'll use it with A. So in this case, I'll use it with A. So in this case, x will become m times x2 plus n times x1 upon m plus n. So the denominator part which is m plus n that remains constant. वो चेंज नहीं होगा. Even for y की वैल्यू के लिए this will remain m plus n only. Only the coordinates which we have taken for x we take for y. So y value becomes m y2 plus n x n y1 upon m plus n. So this is how we are going to find the values or coordinates of x and y. Coordinates of P which are x and y. So this is very important to understand, like how we are using m is to n ratio, which we have here, how this is used to get the coordinates of P, which are x and y. So this is a section formula. This is applied when we have a point bisecting the line into equal lengths, or maybe in 2:1 ratio or 3:4 ratio, whatever ratio it is. We can find that particular point. So you will see the examples here in the coming slides. Okay. So I'll move to next one. So this is the scenario when we have a point which divides the line into two equal parts. So equal is missing here. I'll update it. But the point is, this is A, this is B, and we have a point C in between, and the ratio between AC and BC is 1:1. So this is the important point to understand, that we have a ratio 1:1, and here we will apply the section formula here, but once we do it, you'll understand that you don't need to apply the section formula, how to find out the answer for the coordinates of C and C. So we'll see that. So I'll use the same thing, x1, y1, x2, y2 for B, and C is x comma y. So let's say that I want to find x, the x coordinate of C, which will be, so I'll use this one with B and this one with A, even though both are equal only, so I can use whichever I want. But I mean, from the section formula, we can understand it like this. So it becomes 1 into x2 plus 1 into plus 1 into x1 upon 1 plus 1. So it becomes x1 plus x2 upon 2. Similarly, for y as well equals y as well, it will become 1 into y2 plus 1 into y1 upon 1 plus 1. So it becomes y1 plus y2 upon 2. So this point you have to remember that if a point C is bisecting the line into two equal parts, that is, the ratio between the parts is now 1:1. In that case, the coordinates of C will be just the addition of both A and B upon 2. Same is for X and same is for Y as well. So if you see here, we that's what we have find out. X of C is x1 plus x2 of A and B and then upon 2. And similarly for Y as well. So hope this is clear. Okay. So the question here is determine the ratio in which the line 3x plus y minus 9 equals to 0 divides the line segment joining the points 1 comma 3 and 2 comma 7. So let's say that there is a point 1 comma 3 and there is another point 2 comma 7. So there is a line joining them and there is another line which is passing through this the line joining them, which is 3x plus y minus 9 equals to 0. So we have to find out this particular point, which is let's say x. So let's say that the ratio here is lambda is to 1. Okay. So it is just a variable that I have used. You can use k as well. So in that scenario, can you tell me what will be the coordinates x, y of this intersection point x? So x equals to, how do I do this? Please tell me. Okay, so we'll have to use this lambda with the far value and similarly 1 with the far value, correct? So it becomes 2 lambda plus 1 upon lambda plus 1, right? And similarly y becomes 7 lambda plus 3 upon lambda plus 1. So what we have done is we have found the coordinates of this intersection point in terms of lambda. So now what we have to do, tell me, I mean, can you guess how we go ahead with this question? So we have this equation, right? So this particular point, since this lies, this particular point that we have here, this lies on this particular line. So it will fit into this equation as well. So that's what I'm going to do now. So 3 into 2 lambda plus 1 upon lambda plus 1 plus 7 lambda plus 3. It becomes 7 lambda plus 3 upon lambda plus 1 minus 9 equals to 0. So now I have to just solve this equation. So it becomes 6 lambda plus 3 plus 7 lambda plus 3. And this lambda plus 1, I can multiply it with 9 and I'll take it to the right hand side. So that becomes null. So it becomes minus 9 lambda minus 9 equals to 0. So this becomes 6 plus 7 is 13. 13 minus 9 is 4 lambda. Again, 3 plus 3 is 6. And 6 minus 9 is minus 3 equals to 0. So lambda becomes 3 by 4. So whatever value that we have set before, so lambda, if you see it was lambda is to 1, right? Now we have found lambda is 3 by 4 is to 1. Or I can say it is 3 is to 4. It is the same thing, right? So if I divide 4 into this one, if this one that is present here, if I put 4 into 4 by 4 here, it becomes 3 is to 4 ratio. Okay, so this is our answer. Now we can go to the next question. So we have the vertices of a parallelogram. We want to find out whether it's a rectangle. Okay, so can you tell me what is the relationship or how do we find out whether these vertices are of a parallelogram? Okay, so let's say this is what we have. We don't know whether it's a parallelogram or not. So it is minus 2 minus 1, 1 comma 0, 4 comma 3, and 1 comma 2. Okay. So how do we find out whether these lie, whether it's a parallelogram or not? Can you tell me? Okay, so one basic thing that we need to understand, if there's one figure like this, can you say that these diagonals, I mean, based upon these vertices, we won't be able to find out, but using these diagonals, we can find out something. So in case it's not a parallelogram, will these diagonals be bisecting each other? So in parallelogram, these diagonals bisect each other. So we need to understand whether this particular point O, let's say O, whether this O, which is the intersecting point of these diagonals, is bisecting both the diagonals or not. So let's say A, B, C, and D. So for AC, what is the middle point that that's what we want to find out. So midpoint is what we are going to calculate here. So if you remember from the previous example, how do we find out the midpoint? The section formula, we are saying that using the section formula, it is 1:1 ratio that we are going to have for these two parts of diagonal. So the midpoint will be for x coordinate is -2 plus 4 upon 2 and -1 plus 3 upon 2 for the y part. So it becomes 2, 1 and it becomes 2 again 1, 1 comma 1. And similarly, if I want to find out for BD as well, the midpoint, it will be 1 plus 1 upon 2 and 2 plus 0 upon 2. That is again 1 comma 1. So now we have understood that for both of these diagonals, the midpoint is same. So that means in this figure, the diagonals are bisecting each other. Okay. So that means it's a parallelogram. Now we have to also find out whether it's a rectangle. So for rectangle, okay, can you tell me now, like what is the property of rectangle that we can use here to find out whether it's a parallelogram or not? Sorry, to find out whether this parallelogram is a rectangle or not. So if it's a parallelogram, it can be, I mean, the next thing that I can think of is, so in parallelogram, what happens? This is parallel to this, parallel and equal. Similarly, this is parallel and equal to this, right? Now, same thing is applies to rectangle as well, that the opposite sides are equal and parallel. But additional thing that in rectangle, what we have, which we don't have in parallelogram is the diagonals are equal in case of rectangle. So let's try to find out the distance of the length of AC and BD. If they are equal, then this parallelogram is rectangle. So for AC distance calculation, what we are going to do is we are going to find out distance, and 4 minus 2 becomes plus 2, but I will just write it down for now. 3 minus, so it is 3 minus minus 1 square. So it will become 4 plus 2 is 6, 6 square plus 4 square. That is 36 plus 16. 36 plus 16 is 52, root 52. So this is what we have found out for the AC. So AC length is 52. Similarly, let's find out for BD as well. So for BD, 1 minus 1 is 0, plus 2 minus 0 is, so 1 minus 1 is 0 square, plus 2 square, so it becomes 4 root 4, which becomes 2. So it is 2, length of BD is 2, and length of AC is root 52, which are not equal. So this parallelogram is not a rectangle, it's only a parallelogram. Hope this is clear. Okay, so we'll move to next question now. Okay, so this is the last question that we are going to do. So here the question is, find the ratio in which y-axis divides the line segment joining A. So let's say this is point A, which is 5 comma minus 6. The other point is B, which is minus 1 comma minus 4. And there's a line joining these 2 points. And so we have to find out the ratio in which the y-axis divides this line segment. So when I say this is y-axis, what is the meaning of this? Can you please tell me? Anything that you can tell me about this point? considering this is y-axis, so that so on y-axis, the value of x coordinate is always 0. So if you see here, we have x and y axis. This is x, this is y. So whenever we move along x, the first part of the coordinate keeps on changing, but the last part of the coordinate remains 0 on the x-axis. On y-axis, if we consider the same thing, the first part will remain 0 if I move up or down here, but the last part will keep changing. Okay, so when I say this point is on y-axis, the first part will remain 0, the second part will be by y. Okay. Okay, so now we have to find the ratio in which these coordinates, ratio by which this line segment is getting divided. So let's say the ratio is k is to 1. Okay. Um, okay. So let's try to find out the value of k first. So we have coordinate of x, which is 0. So let's try to find out using that. So 0 equals to, we are going to use k with the far value. We are going to use 1 with the this far value here. So k into minus 1 becomes minus k plus 5 upon k plus 1. So it becomes k plus minus k plus 5 equals to 0, which becomes k equals to 5. So therefore the ratio becomes 5 is to 1. Okay. Now we are going to use this to, as the question says, also find the coordinates of the point. So we have to find out 0 comma y as well. So we have to find out y as well here. But now since we have k, we can find out y as well. So y becomes, I'll put k as 5. So k, this 5 into minus 4, which is here. So it becomes 5 into minus 4 plus this 1 that we have here. It will go and multiply with this minus 6. 1 into minus 6 upon 5 plus 1. So this becomes minus 20 minus 6 upon 6. So that becomes minus 26 by 6 or minus 13 by 2. Minus 13 by 3, sorry. I'll divide it by 2, right? So it becomes minus 13 by 3. So therefore the point becomes 0 comma minus 13 by 3. So that's how we have found out both parts of this question. First we had to find the ratio and then we have to find the coordinates as well. So hope you understood the video. All the questions inside this video as well. Okay, best of luck. See you next time.